Now, the topic of polarity also comes up when we're looking at molecules. When you look at molecules, you have to take into consideration all of the bonds and how they're working together. In a previous video, we talked about the polarity of bonds. And when you're doing the polarity of bonds, you look at the differences in electronegativities. But when you're talking about the polarity of molecules, and you have to take into consideration all of the bonds, if we were really doing this, we'd have to look at vectors and how they add and cancel together. But there's a few considerations we can take, and it will help us get a good idea if a molecule should be polar or nonpolar of what we would predict. So I've kind of written it down in 2 basic steps, but it's really kind of 2.5, because at step 2 you can see there's an A and a B. So what we have to look at when we're thinking about polarity of molecules is how things are connected. So we're really looking at the Lewis structures. And what we have to consider is that if bonds of different electronegativities are attached to each other, then they're going to pull or attract electrons differently, and ultimately it's going to cause the electron cloud not to be equal. So when we talk about a polar molecule, what we're saying is that the electron cloud is not equal or even around the central atom. When we're talking about a nonpolar molecule, we're talking about molecules where the electrons are shared evenly or equally about the molecular atom. So those words polar and nonpolar really kind of mean the same thing, where nonpolar means that the electrons are evenly distributed around the molecule, and polar means they're unevenly distributed around the molecule. And anytime electrons are unequally distributed, it creates areas that are partially positive and partially negative. So to take into consideration, what we have to look at is the Lewis structure. And the first thing we're looking at is number 1. We want to look at our central atom and see if there's any lone pairs. So if I look at examples 1, 2, 3, and 4, I want you to look at those Lewis structures and just sit there, just think about it. Which ones have lone pairs on the central atom? Not just everywhere, but on the central atom. 2 and 4. So water right here is a polar molecule. The lone pairs on the central atom help us see that the electrons are going to be unevenly distributed. And then NH3, this is ammonia. And so I can simply, when you have the central atom there, I see there's lone pairs. It helps me decide that I would predict that is a polar molecule. Now, number 2 says, well, what if there are no lone pairs on that central atom? Remember, we're looking at the central atom when we're talking about the lone pairs. Well, then I have to have some other things that are considered. So number 1 and number 3 have no lone pairs on the central atom. Both of them have carbon in the middle. So when you have no lone pairs in the central one, you're going to look at the surrounding atoms, the atoms that it's connected to. And we have 2 choices. The first example would be if they are all the same element. If they are all, oops, this says not all, sorry. If they are not all the same element, apologize. So if they're not all the same element, then it's polar. And remember, polar means that you have an uneven distribution of the electrons. You have partially negative and positive areas in the molecule. So if you have different elements, they have different attractive powers, and that's what causes it to be uneven. If they are all the same element around them, the central atom, then it becomes a nonpolar molecule. So here I look at the carbon and I see that all 4 things are chlorine. So that means all the surrounded atoms are the same element, and this guy is nonpolar. So those electrons would be evenly distributed around the around the molecule. Here I look at the carbon, and again, I have 2 oxygens, so they're the same. So this would also be nonpolar. Well, what if I had this? If I had HCN. It doesn't have lone pairs on the central atom, carbon, so then I look here and I see there's hydrogen on one side and nitrogen on the other, so it has different elements, so this would be a polar molecule. If we investigated further, we'd see that the electrons, nitrogen has a higher electronegativity, and we would notice that the electron cloud would be a little bit more around the hydrogen. So read the questions carefully. When it's talking about the polarity of molecules, we're not necessarily going to use electronegativity, but instead we're going to look at the Lewis structure. First, we can look at the central atom and see if there's lone pairs. And if there's lone pairs, that creates an unequal distribution of electrons, and that's a polar molecule. But if there's no lone pairs on the central atom, you have to look at the elements that central atom is attached to. And if those elements are all the same element, any poling that they might have, attractive forces cancels, and it's a nonpolar element. If there's different elements around the central atom, those attractive forces don't cancel, and it creates an unequal distribution of the charge, and you have a polar molecule.